This is an expressive practice sample. You have been asked to render a message for a deaf upper elementary school student. The class is beginning their unit on volume. You will have a 1-minute warm-up followed by a 1-minute break. After the break, you will begin interpreting or transliterating. The warm-up will begin momentarily. So, we all remember learning area and perimeter. But now we are going to learn about volume. So I'm going to explain what volume is. I'm going to teach you the equation for volume, and we're going to do a couple practice problems. Hopefully, by the end of this, it'll be pretty clear. But if you have any questions, don't be afraid to ask. I'll request that you wait until I'm done explaining, just in case my explanation answers your question. That way we're not stopping and starting too much. Volume builds upon what we learned about area and perimeter. So we'll review those quickly and then jump into today's topic. So let's quickly remember everything that we learned about area and perimeter. So perimeter is the summary. It is the sum when you add up the sides of your shape, right? So if you have a square and every single side is 2 feet long, then 2 plus 2 is 4, plus another 2 is 6, plus another 2 is 8, right? So the perimeter of your square is 8 feet, right? Perfect. And then when we learned area, we learned that the area of a space is length times width, right? So for example, if we have that same square and the length of every single side is 2 feet, then the length times width is 4 feet squared. Good job. Now, with volume, we're measuring the full dimensions of something, right? So when we talked about area and perimeter, it was like we were measuring a piece of paper. How long are the edges of the piece of paper? How big is the surface of the piece of paper? That's what we found when we found the perimeter and the area. But with volume, it's like we're measuring how much space a box takes up, because a box is also tall, right? A piece of paper is flat. It only has an area and a perimeter, but a box is also tall. So if you want to measure the full amount of space that a box takes up, you also have to think about how tall it is. So when we're finding the area, when we're finding the volume of something, we are doing the length times the width, just like area, times the height of something. This is showing us the full amount of space that this shape takes up, okay? For now, we're only going to practice with like boxy shapes, okay? All kinds of shapes have volume, like circles and cylinders, but we're just going to focus right now on cubes, which are like squares, and what's called a cuboid, which is like a cube but a rectangle instead of a square. And I'm just not going to say cuboid because you don't really need to know that. So I'm just going to say box, okay? So we now know the equation for volume is length times width times height, okay? So when you have a cube, it's kind of similar to what you do when you're trying to find an area, right? So the process for finding an area is really similar to when you're finding volume. So let's take our same shape as before, except now instead of being a square, which is two-dimensional, we have a cube, which is three-dimensional. We are going to do length times width, which we got before was 4, times height, which is 8. And so for the area, we say that something is however many feet squared. For volume, we say it's however many feet cubed, okay? So it's a little bit harder when we have a box instead of a cube, right? It's almost the same problem we run into with finding area and perimeter. With a square, all of your sides are the same, so it's super easy. But with a rectangle, your sides have different amounts. So you have to think a little bit more, right? That happens when you're finding volume too. So let's say we have a rectangle that is 10 feet by 4 feet, okay? So we know the perimeter is 10 plus 4, which is 14, plus 10, which is 24, plus 4, which is 28. So we know our perimeter. And then our area is length times width. So our area is 4 times 10, which is 40 feet squared. Got it. Now, let's imagine that this rectangle turns into a box, okay? It goes from being two-dimensional to being three-dimensional. So now we're going to find its height. Let's say that it is 3 feet tall. So our length is 10 feet times our width of 4 feet. What do we get? 4 times 10? 40, correct. And then we take our 40 times the height of our box. How tall is our box? 3 feet. So 40 times 3 equals what? 120 feet cubed because it is three-dimensional, okay?